list is a linear data structure in which each element contains the location of the next element or elements. Linked list is similar to array, but in array we cannot insert an element or delete an element at the middle or at the front or at the beginning. But in linked list it is simpler when compared to arrays. Also, a node in a linked list has two parts, the data part and the link part. The link part contains the address of the next node, which establishes the connection between nodes. A node in C is represented by a self-referential structure. A structure called node is created which contains int data and struct node star next. Struct node star next holds the address of the next node and hence it is a pointer.
Creation of a singly linked list. So we know that we've previously seen how a node can be represented. So if we're going to create a singly linked list, first we assign structure pointers. Like example, in this code we've used first, second and last. So for first we get the data from the user and store it into first of data, and then next after that we make the last pointer point to first, because when the node is created, when the first node is created, the first node and the last node are the same node, right? So afterwards we get the size of the linked list data structure that we are going to be using, and we input the size into the for loop and we make the loop repeat n times. So the block of code inside the loop repeats n times, and the block of code inside the loop is mainly for creating the next nodes after the primary node. So the second node, which is basically a current node which keeps being created, it's similar to the first node where we allocate memory to it, and afterwards after we allocate memory to it and get the user from the data and store it in second of data, there's a small slight change where since the previous node is now being referred to as last, right? So last of next is made to be pointed to the current node, which is the second node, and last is made to be pointed to the second node because the newly inserted node becomes the last node, right? And after the loop has ended, there is no value present after the last node, right? So last of next is made to be pointed to null. Next we're going to see how to print all the data present in the linked list structure. We create a separate function, but the main contents of this function, it's not a necessity to create a function, but the main logic is that basically you take a temporary node and we allocate memory to it, and the temporary node is used for traversing through all the elements, through each and every element of the linked list. So first we check if the first node is null, and this is done to see if there is a linked list present or not. So if the first node is null, it basically means there's no value, right? So the linked list doesn't exist. So if first is not null, in the else part we assign temp to be first, and we use a while loop when the condition being temp is not null. So basically it goes to traverses every element until temp becomes null. So temp will only become null after the last node, because the last node, there's nothing present after the last node. And inside we print temp of data, and to make temp to traverse the next nodes, we assign temp is equal to temp of next. So this points to the memory address of the next node, which gets assigned to temp, and temp of data will print the value of the next node. So this is how the basic logic works.
Insertion at the beginning. In order to insert a new node at the beginning of the linked list, a node is created using malloc function. The data for the new node is got from the user. Then the logic behind inserting a node at the beginning is new of next is equal to first and first is equal to new. The line new of next is equal to first means the link part of the new node is equal to first. That is, there exists a connection between the new node and the first node of the linked list, and first is equal to new means the first node is new node is updated to be the first node. Insertion at the end is similar to insertion at the beginning. In order to insert a new node at the end, we have to create a memory space for the new node using malloc function and get the data for the new node, similarly as we did in the previous part. Here we perform last of next is equal to new, which means initially the new next part of the last is null, but here we assign it to the as the new node. So in order to establish a connection between the last node and the new node, and then finally we update the new node as the last node. Insertion at the middle is a bit complicated than the previous insertions. In order to insert a node at the middle, we create a new node using malloc function, get the data of the new node. In addition, we also get a data called x. Here x is the data after which we have to insert the new node and move a temporary variable till the data of the temporary variable is x. Assume in this linked list we have to insert a node after 20. So we move the temporary variable till 20, and in order to establish a connection between the temporary node and the new node, we usually do temp of next is equal to new. But if we do that here, we will lose the address of the node of data 30. So before doing this, we have to first establish a connection between the new node and the node of data 30. So we do new of next is equal to temp of next. This establish the right connection. And then after that we update the next part of the temporary variable as new, and so the connection will be established. Thus 25, the new node will be inserted at the middle after 20.